Alright, so the section that we're on is about triangle congruence, meaning how to tell if two triangles are going to be exactly the same as each other. This is a little foldable. If you want to trim it, you can, but you don't have to. You're just folding this inward. But like I said, if you want to trim around the outside, you can, because the actual, I guess, rectangular part is smaller than the paper. But basically, you're folding this in half. Yeah, be careful if you are going to trim it, not to cut the words off. But basically, you're just trying to see the names. Okay? And so, on this little foldable, if you want to, you can trim on the lines on the front so that you can open just one at a time. That's a personal choice if you want to. But these are all the arrangements of 3 parts of a triangle that there can be. You can either have all 3 sides, all 3 angles, 2 angles and a side, 2 sides and an angle. And this one looks like it's only giving you 2 pieces of information, but we only call a triangle, call a side of a triangle a hypotenuse if you have a right angle. So hypotenuse leg still has an angle, because it would have to be a right triangle to be called a hypotenuse. So any variety of three parts, because you have 3 angles, 3 sides. This covers every single possibility of 3 pieces of information. And it will tell you whether or not, if you have those specific 3 pieces of information, whether your triangles are congruent or not. Okay? So when you open them, the 2 that are 3 that are postulates, and remember, postulates are the part that you don't have to prove. You get to accept without proof. The postulates are the 3 sides, 2 angles in the side in between, and 2 sides and the angle in between. Those 3 are the original. Remember, we talked about postulates don't have to have proof. Theorems did. You use these 3 to prove all the theorems.
Wait, you said the what?
The ones that say postulates I highlighted. The 3 sides, the 2 angles and the side in between, or the 2 sides and the angles between. They're going to just use S's and A's for, I guess, just to make it faster. S stands for sides, A stands for angle. So this is the side congruence postulate, but you don't have to write side 3 times if you just put SSS. Okay? Now I will tell you, make sure you put this symbol, and the reason is the next section that we cover will be similar triangles, and some of these 3 sets of letters have also rules for similarity. So you don't want to just say SSS, because then are you meaning congruence or similarity? So at least put the congruent symbol, even if you don't write out the word postulate or theorem. Okay? So these 3 are true always. If you have all 3 sides of one triangle marked equal to all 3 sides of another triangle, they're going to be exactly the same. And that goes back to that triangle inequality theorem where we talked about the biggest angle was across from the biggest side, the smallest angle was across from the smallest side. If your 3 sides are the same, there's no way your angles could be different. Okay? If you have just 2 of your angles marked as the same, but the side in between them, so notice this side, it's in between where the angles are. So that's why when we write ASA, the S is between them. That's different than AAS. Okay? AAS would mean the 2 angles were in a row and then a side. Okay? Same thing here. If you have 2 sides and the angle in between them, because see how the angle is formed by the 2 sides that are equal? There's no way that the other parts could be different. Mathematically, it just won't work. So these are your 3 starting places. Now the other 2 that you have here that are theorems, they're both versions of these. And what I mean by that is they use these rules to create this one. Because if you think about this one, it has 2 angles and a side. But based on the fact that we know triangles always add up to 180, doesn't that mean that the 3rd angle would also have to be the same? Yeah, if you knew this one was 60 and this one was 70, then you could do the math and you would know that if this is 60 and this is 70, then both of these are going to be 50. You'd have to do the math, but The point is, if you have two, you know the third angle is equal. So if I marked that one, then this would be exactly the same as this one, because I would have angle, side, angle. So this is a theorem because it's derived from this one. The good news is you get to use it without going through all that process, but that's why it's a theorem instead of a postulate, because this one created this one. And this one is special all on its own. Like, it's not like any of the others. Because if you look, it's a side, then another side, then an angle. This angle is not in between the sides. Okay? So when you have side-side angle, right, like this one right here, it says no, that doesn't prove that they're congruent. The reason this one's special is because that angle specifically is a right angle. We could do Pythagorean theorem here. And if two of our sides are the same, the third one's going to have to be in a right triangle. Okay? But this shows that if I have two sides that are equal and an angle, they don't have to be the same triangle. Okay? So this one's special just because it's a version of this one where it's actually true. And this one's saying it's not true. So don't assume if you have two sides and an angle that it's going to automatically be congruent. If you have two sides and an angle and the angle's in between them, it's congruent. Or if the angle's a right angle, it's congruent. Otherwise, having two sides and an angle is not necessarily going to prove anything. And then the last one is if you have all three angles, they're definitely going to be similar. If you have all three angles the same, it's going to work to be similar. But one could be bigger than the other. Okay? And that's why this one says that you can't prove they're congruent. It says may be similar. And what they mean by that is it may be similar instead of congruent, but it's definitely similar. Okay? So they really should put triangles are similar instead of maybe. They just meant maybe instead of. Okay? So all of these, there's 1, 2, 3, 4, 5 that do prove congruence and 2 that don't. Okay? This is every possible combination of sides and angles. So on your assignment, you're going to look at which ones they mark. So just as an example, if you look, let's just look at number 5. Number 5, all it has is a right angle. Okay, and if this one's a right angle, then this one is too, right? Because of that linear pair adding up to 180. But they don't mark any sides equal, except for the obvious side here, AY, they share it. So it's going to be equal to itself because it's shared in both triangles. But we don't have another angle or another side marked or another way to figure out that they're true. So 2 pieces of information are never enough. Okay, every single one of these had 3 pieces of information, like every single one. Okay, this one doesn't look like it has 3 because it just says HL, but it also has a right angle, so that's really a 3rd piece. Okay, so this one, when you're looking at the directions, it says determine if they're congruent. If they are, name the congruence. That's like which rule. Okay. Oh, well, that's this part. And then I will talk about the naming in a second. And it says show any of your markings, which like I did on number 5, I marked it. And it says if they can't be proven congruent, state not possible and give the reason. So I would say not possible. And my reason is not enough information. 2 pieces of information wasn't enough to say anything. We're not saying that they couldn't be. Okay, sorry, let me zoom in. We're just saying that you can't prove that they are. Okay? They look like they are, but they didn't tell us for sure that this piece was the same as this piece, or this side was the same as this side, or that this angle and this angle match. They didn't tell us any of that. They could be close, but like if this is 59 and this is 60, they wouldn't match, but they look like they did. So that's why. So the reason is not enough info. Or you could write it all out if you want to spell information. Okay. Now, let's look at one that is. And I will tell you, I am sorry, the copy machine did not do great. On number 6, there's some markings here that are too faded. So on number 6, you can see this one pretty good, but you couldn't really see that one. I apologize about that. But we'll look here. This one has 2 sides marked as equal and the angle in between. So is 2 sides and the angle in between any of these? Which one? Well, H is the hypotenuse. Now I know why y'all picked that one, because it was the right angle one, right? Yeah. But do you see how the side here is the one across from the right angle? On this one, across from the right angle is not the one marked. So it's not HL, but it's still two sides with an angle in between. Is that one of our other ones? Yeah. So you're going to say yes. And you're going to say it's by the side angle, side congruence postulate. It wants you to tell, to name the triangle congruence. So on this part, sorry, that was over. On this part, you have some freedom a little bit. Your answer doesn't have to match your neighbor's, because we talked about naming triangles is with 3 corners, but order doesn't matter. So how could I name this triangle? Okay, so CDE. The first one that you do, it does not matter what order you put, because the 3 corners in any order will be the name. But when you put what it's congruent to, you do have to make sure to go in the same order. So we did C first. So on the other triangle, what one would be corresponding to C in the same location? Yeah. And then, of course, D is G, like Cameron said, because that's where the right angle is. And then E would be the one this across the small side. So, as he said, that's H. Okay. So we determined if they're congruent. We named the triangle congruence. We identified the theorem and the postulate. And they already had all the marks here. I just made that one darker, because I will say you just couldn't see it very well. At least I couldn't. Maybe you could have saw it easier than me. But I'm going to go through real quick and tell you which other ones the markings are not great on. I'm sorry, the copy machine must have been getting low on toner, because you just can't see all of them very well. So on number 1, the only markings are the angles at the top and the side here. 2, you can see pretty well also. At least on mine I can. 3 is hard to see though. There's an angle here and here. There's the 2 marks and the 1 mark on this one, 1 mark and 2 marks on this one. So this is not me giving you the answers, just making sure the marks can be seen clearly, because I'm sorry about them being a little faded. That's on 3. I haven't moved to 4 yet. Everybody got 3? All right. 4, the one that you couldn't see very well was the side with 1 mark, but it is there. We did 5 and 6. 7, there's a 1 angle mark here and a 2 angle mark here. There's a 2 angle mark here and a 1 here. There's a side here and a side here. That one was really hard to see, at least in my opinion. On 8, the only mark is here and here. And then on 9, there's a mark here and here for the angles, and there's a mark here and here for the sides. So I apologize for those not being super clear. Now, the back has a different set of directions. No. None of these have the marks on the pictures. They're all in the words. So I will tell you, we're going to go more into detail with proofs tomorrow. But a proof is like a set of steps that prove something is true or not true. So there's no marks here that you can't see. They give them in words. But I will tell you that don't start on this part, because we're gonna go over proofs tomorrow. Okay? But when you see it, you're going to name the triangle congruence. So that's like triangle ABC is congruent to triangle DEF, like we did on the other one. You're going to give what theorem or postulate, and if they can't be proven, you're going to state not possible. But I will show you how to do an official proof tomorrow. So you can do the other part. You just won't be able to do it in a proof format. But I'd start on the front today. That way, if you don't get finished, you're right where we are tomorrow. Are there any questions about how to name the triangle congruence or how to tell which rule? Anybody not get one of the markings on the front?